Bonjour, I'm a senior software engineer at Uber in San Francisco, and today I'm going to explain a LeetCode question to help you prep for your interviews. I'm going to solve all the questions from a list called Blind 75. So you see there are 76 questions, and the first one that we're going to solve today is called toSum. Given an array of integers and an integer target, return indices of the two numbers such that they add up to target. You may assume that each input would have exactly one solution, and you may not use the same element twice. You can return the answer in any order. So let's go through the examples together. Example 1. Nums equal 2, 7, 11, 15, target equal 9. So we are trying to find two numbers that adds up to 9. Here we can see that it's 2 and 7, because 2 plus 7 equal 9. So, this is indices 0, 1, 2, 3. So we see that 2 plus 7 equal 9, and this is indices 1 and 0. So the output will be 0 and 1, and they said in any order, so it could be 1 and 0. What about the second example? 3, 2, 4, target equals 6. So we see that 2 and 4, so 2 plus 4 equals 6. So it is 0, 1, 2. So indices is 1 and 2, and for example 3, we don't have much choice, but it's 3 plus 3 equals 6, and it's indices 0 and 1. So let's talk now about the solutions. I will describe two solutions. The first one will be a brute force solution, and the second one will be a more efficient solution. So in an interview, you can talk about the first one just to give you ideas, but the interviewer will expect the second one, the more efficient solution. So let's start with the brute force solution. This solution will pass LeetCode just because they kind of expect people to do that and then to come up with another solution as written here. Can you come up with an algorithm that is less than O of n squared time complexity? So let's still go through the brute force just to see how it goes, and then we'll go to the more efficient solution. So brute force is usually like we try all the different possibilities, or almost. So we usually have two for loops, one inside the other one. So let's do it. For I in range len of nums, for j in range len. So we could start at I plus 1 to len of nums. And the test is pretty simple. It's if nums of I plus nums of j equals target, then we return in any order I and j. So let's run the code. So this works, and now if we submit, it should work as well. But we can do better, and we will do better. Yes, so it works, and you see that the runtime is pretty bad. So before jumping to the second solution, let's first talk about the complexity. So we want to know the space complexity and the time complexity. Space, we see that we don't use any external variable, we don't store any arrays or anything, so it is O of 1. Now time, we see that we iterate through the array nums with a for loop inside another for loop, so that's the typical O of n square. So now let's talk about the more efficient solution. So we have this array 2, 7, 11, 15 and the target 9. what we want to do is when we are at a number, let's say 2, we want to know if 2 plus something equal 9 exists. If yes, we return the index of this number and what we found. So the thing that we just did now is like 2 plus x equal 9, trying to find x, so x equal 9 minus 2 equals 7. So the question is, do we know target minus the current number, does it exist? So if we go one by one, we can ask. So let's start with here. Do we have 9 minus 2 equals 7? No, not yet, because we haven't went through the array yet. Now the second one, we do 9 minus 7 equal 2. Do we have a 2? Yes, because we've been storing this 2 in a hash map. Why a hash map? Because there is a constant lookup to that, and it will be super helpful for our complexity. So what we do now is when we go through for num in nums, we want to store, for example, if we have a hash map called scene, we want to store the number, so num, at the current position. So at the beginning it's 0, 1, 2, 3 at the position. So now let's code the more efficient solution. So we know that we need a sort of hash map to store the value and the position. Now if we iterate over the array, so we do for index value in enumerate of nums. What do we want to do now? We want to know if the target minus the current value exists somewhere. So we can create remaining equal target minus value. And the question that we need to ask ourselves now is if do we have remaining inside our hash map? If yes, then we found the solution, so we can return index as well as scene of remaining. Else, I mean, we don't need else, but let's say we do. Else, we want to store the correct value and index in the hash map scene. So we have scene of value equal index. And that should be it. Let's see. And then we'll go through an example together. Okay, submit. Okay, good. So let's go an example. We have this one. So index will be 0, value will be 2, remaining will be 9 minus, because target equal 9, 9 minus 2 equals 7. Do we have a 7 inside scene? No, not yet. So else scene of value, so scene of 2 equal 0. Now second element in the array, 7. So remaining equal 9 minus 7 equal 2. The question is, do we have a 2 in the hash map scene? The answer is yes. So we return the current index, which is 1, and scene of remaining. This means the value at the key remaining, so remaining is 2, which we stored previously at index 0. So now the answer will be 1, 0. Now let's talk about the complexity of this solution. Complexity, so we want space and time. The space complexity, we see that we are storing every value, key value, value and index in the hash map. So it means that the complexity is O of n because we store everything maximum n times. And now the time complexity, we do one for loop over the array nums. We do it only once, meaning like, you know, there is no two for loops within each other. So the time complexity is O of n as well. So yeah, I hope that was helpful. I'm going to do all the blind 75 LeetCode questions, 76 questions over the next few months. So yeah, subscribe to know more. Peace.